start sharing my screen. Okay. So inch.
What's cool is after he's done, he uploads the slides to Blackboard, and even though it's handwriting, you can select text. I have no idea how Apple does that.
Type. I don't have an idea also. Can you turn off your mic, please? Mute your mics, Shabab, so that I don't hear your conversations. It's good this time was good, and it was not bad conversation. But anyhow, inch 200, and today is February. I always write February wrong. February. Today is 9th or what? 10th. Oh, it's here. 10th. 2021. Okay. And today we do continuous random variables. And we'll see how much we can advance and if we can get into the families of continuous random variables, because you are now you should know better about random variables than when we introduce the discrete random variables. Okay, let me do one announcement. The midterm is as is. Midterm exam as is. Some of you with 3 exams, I will shift. You still will get the exam the same day, but I will shift the timing for them. I will be in touch with you. As you know, because I'm receiving emails that some of you have 3 midterm exams on the same day, and I guess a couple of you have an exam at exactly the same slot. And I received an email from one of the students, I'm not sure from this group or from the other group. He's saying that I should stick to the lecture timing. So the slot I'm using for the midterm, no, it's a free slot. You should not have any other courses in that slot. So the same thing that another professor did, I'm doing. So for those who have another exam in the same slot, I will be in touch with them so that they send me when was the other exam announced to them. If it's announced after this one, they have to talk to the other professor to switch the timing of the exam. If our exam was announced after their exam, then I will switch the timing for them. Okay. So let's start with today's lecture. So today we will do the continuous random variables. As you recall, random variables. Let me say recall. And yeah, I forgot to upload this. I told you before that I have a set of slides for this course. If you want, I will upload them just for your information. If you want to consult with the slides, it's more or less what I'm writing. I'm sometimes write different things or different examples. Let me close the door. I think there is some noise from the bird. I'm teaching from home today, so okay. So recall that random variables, if you recall, are functions that map the outcomes of a random experiment 2 are or part of it. And we said in case of discrete random variables, range is discrete, while what we are doing today for continuous random variables, the range will be all the real line or part of R. Okay, and also recall that in general, when we started talking about randomness, we said discrete random variables deal with things that are counted. So any type of randomness that you can count, the number of errors, the number of messages, the number of students, the number of deaths, all of these are things that you can count. So it boils down to be a discrete random variable, while continuous random variables deal with things that are measured. Temperature, pressure, depth, height, weight, all of these are things that are measured, and as you'll see it, we characterize it using continuous random variable. Okay, طيب. So characterization of continuous random variable, like we did with discrete random variable, we talked about different ways of describing a random variables, the small f of x, the capital F of x, the mean and the variance. We'll do the same for continuous random variables. So characterization of continuous random variable. And the first way of characterizing continuous random variable is what we call the probability density function, or the BDF. And if you recall, we call it f of x. And let me write it down, the definition of the f of x in the continuous domain, and then we give some examples. So for a continuous random variable x, f of x is defined such that f of x is greater than or equal to 0. If you recall, this is the same thing that we had for the random variable. So probability density function is a positive entity. Okay, we know this. The second thing that is different, in the case of discrete random variables, we mentioned that the summation of f of x equals 1, right? For discrete. So what's the counterpart for the summation in the discrete domain? We know that the counterpart of summation is the integration. So the integration from minus infinity to infinity of f of x dx is 1. The way we characterize small f of x in the continuous domain. The area under the curve, because now we have a curve, we do not have specific properties, probabilities at specific values. We just have a full curve that we draw to show the distribution of probability over a whole range. Number 3 is that the probability that our random variable is between two specific values is simply defined as integration from a to b dx, which is, i.e., it's the the area under the curve in the selected range. So this is the, this is the definition or the characterization of the small f of x in the continuous domain. So let's reflect on this and compare it to the case for what we had in the discrete domain, and then we'll do some examples. So if you recall, important note, let me write this in my notes. If you recall, in discrete random variables, what was small f of x? F of x, how did we define it? Anyone? How did we define f of x in the discrete domain? I just did the quiz last week.
Probability x equals x.
Capital X equals small x. So it's the probability that my random variable takes a specific value. This was the, let me turn on your chat. Okay. So probability that my random variable takes a specific value. So in that sense, for discrete domain, we call it, for discrete, f of x is a probability, right? It's probability of x equals x, which means f of x is between 0 and 1. Cannot be greater than 1, cannot be less than 0. However, in the continuous domain, I do not have a definition, a direct definition of f of x, that f of x equals something, right? Say, so in the continuous domain, f of x is not really a probability.
Doctor?
Yes.
We can take the definition we did, bigger than a, less than b, and take b equals a.
Okay. What happens then if you integrate any function? Yes, so it's 0. coming to that point. This is an important point. I'm coming to that point. But let me finish writing this. So f of x is not a probability, but rather a function used to calculate probabilities. So you can think of it. You can think of it like f of x dx is the probability that my random variable is between x and less than x plus dx. And as you mentioned, f of x, f of, or for continuous random variables, also probability that x equals 0 always in continuous random variables. So in continuous random variables, it does not make sense to talk about probability of a single point. We do not talk about probabilities of single points, but rather probabilities of ranges. Because as you mentioned, as one of you mentioned, integration from a to a, f of x dx, which is probability that x is less than a greater than a, which is probability of x equals a, is 0. So in the continuous domain, we don't talk or calculate probabilities of points, but rather probabilities of ranges, as we will see. Okay, so this is the most important part that you should have in mind. In discrete domain, probability has fixed values, so you distribute the probabilities over fixed number of points. That's why you have certain probabilities for certain points. However, in the continuous domain, we have a curve of probabilities, so we do not have a probability of a single point, but rather probability of ranges between two points. And hence here, f of x is used to calculate the probability of a range between A and B. And that's why also, if we continue with the same note, this means that if I write probability of x to be between x1 and x2, this is exactly the same as writing x1 less than without the equal. This is exactly the same as probability of x1 less than or equal to x less than x2, and it's exactly the same as x1 less than capital X less than x2. Why? Because the probability of a single point is 0. We do not have. So whether you have less than or equal or less than does not matter, because when you integrate, you will integrate from the same point. Let's do an example. Let me see what examples do I have. Okay, I have this example. So let X be the X denotes the whole second. X denotes the diameter of a hole, denotes the diameter of a hole in a sheet, in a metal sheet. So when you use a drill, resulted from drilling. Okay, when you drill a hole in a sheet, of course, by our eyes, it may look like it has the same diameter for all if we do it multiple times, but if we do exact measurements, it's not it's not exactly the same. So as we know from history, we know that X can be modeled as a random variable where f of X is 20 e to the minus 20 x minus 12.5 and x is greater than or equal to 12.5. So this is the distribution. We know that people who work in that factory that manufacture the drill, they know this from history. They manufacture those drills and they did a lot of experiments, and based on the data, they feed the data into, later on we will see that this is an exponential distribution. But f of x can be any function. So we can ask, let me continue with the question. So A, let's say, what's the probability that the diameter is between 12.5 and 12, or let me say, because I'm coming up with this, what's the probability that the diameter is less than 12.6? So this function, if you plot this function, so this is x, this is f of x. We know that x is greater than or equal to 12.5, so it starts at 12.5. What's the value at 12.5? If you substitute x with 12.5 is 20 e to the minus 20 times 0, so e to the 0 is 1, so it starts from 20. And then as x increases, this is an exponential distribution, so we know that it will be like this. And I'm asking, what's the probability that the diameter is less than 12.6? So say this is 12.6. So basically what I'm asking you is to find this area. So probability of x less than 12.6 is the same as probability that x is between 12.6, and we know that it starts from 12.5. So basically this is integration from 12.5 to 12.6, 20 e to the minus 20 x minus 12.5 dx. And for this kind of integration, I expect you, if I ask you this in the exam, you should be able to do it. So this integration you can take. So this is, you can take the 20 outside, and then you can take also e to the minus 20 times minus 12 0.5, and integration from 12.5 to 12.6 e to the minus 20x dx, and then you solve it. You integrate it, you divide by 1 minus 20 e to the minus 20x, and then from 12.5 to 12.6. Don't get scared from this large number, because you will have it will be multiplied by exponential with a large negative number, so it will cancel. Okay. And you can ask, this is not the simplest example that we can start with. We can do probably an easier example. Let me do another example. Let me see if I have. Let me come up with an example. I also can ask, given the below f of x, is it a valid probability density function? I can also ask this in the continuous domain. So I can either give you something like this. For example, this is like 0, this is 2, and if I said this is a, and then for a equals 2, is this a valid BDF? So what are the conditions? We have to check two conditions. So check two conditions as you did in the quiz. First condition, f of x greater than or equal to 0. Is it greater than or equal to 0 in this example? So this is my function. Let me. Yes, it is. So it has value. It does not go under the x-axis. So first condition is good. The second condition is what? Check if integration from minus infinity to infinity f of x dx equals 1. So meaning, check the area under the curve. what's the area under this curve? This is a triangle. So we know that the area is 1/2 times 2 times the height, which is a equals 2. So the area is 2, which means what? Is this a valid probability density function? Anyone?
No,
No?
not valid.
So no. So that's here I can ask for what value of a. I can ask you also this, what for what value of a if x is valid, is a valid BDF. For what value of a? What should a be so that I have the area 1? Area is simply 1/2 times 2 times a, which is area is 2 over 2a, which is a. The area is a. So a should be what? A should be 1, right? For the area to be 1, and for f of x to be a valid BDF. I also can ask you, what is probability that x is less than 1? What is the probability that x is less than 1?
1/2.
Yeah, by inspection, you can right away say it's 1/2. Yeah, because this is a rectangle, and then the area, half of the area is 1/2. So yes. So in principle, the way to do it is integration from minus infinity to 1, f of x dx, and we know that the function starts at 0, so this is integration from 0 to 1, f of x dx, and then this is 1/2 by inspection. Okay. Let's do the other way of characterizing the continuous random variable, which is the capital F of x. Cumulative distribution function. Give me 1 second, please. Okay, sorry. So capital F of x is defined for continuous random variables. Is defined the same way. It's the probability that x is less than or equal to x. So there is no difference in the exact definition of the capital F of x. In this case, since we are talking about continuous function of f of x, the way we define it is integration from minus infinity to x. So integrate the function all the way from minus infinity to x, and then you use another variable u, because you used x already in the limit of the integration. And here, of course, x is plus infinity to minus infinity. So capital F of x, again, is defined as the same way. It's a cumulative distribution function. So you add, in discrete domain, we used to add all probabilities from minus infinity. We move from minus infinity to infinity, and we add probabilities as we move on. Here, also, we move from minus infinity to infinity, and we add areas. We add areas as we move on. Okay. Type. Let's do an example. So given this f of x, for example, small f of x, which is, as we will see, this will be a uniform distribution. So f of x equals 1/2 when x is between 0 and 2, and then 0 otherwise. And I'm asking you to find capital F of x. There's no question mark after find. Find f of x. How do we find it? Again, use the rule. If you always use the rule, you will not do mistakes. And some of you did mistakes in the quiz because you did not use the rules. I'm asking you, find capital F of 3 in the exam. I got like few answers in some of the functions that you got. There was no 3 in the range, so they told me it's not in the range, so it's 0. You cannot just say that. Let's just apply the rule. F of 3 is the probability that x is less than or equal to 3, and you count all probabilities up to 3. So if 3 is larger than the range that you are given, then the probability is 1. If 3 is less than the ranges that of the random variable, then it's 0. So just use the definition. Always use the definition of what I'm asking for. So let's use the definition. So we know that f of x is defined as integration from minus infinity to x, f of u du, which is integration. We know that instead of minus infinity, we start at 0 to x. And what's my f of x? We know that's 1/2 du, which means that do the integration. This is 1/2 u from 0 to x, which is what? If you substitute x minus 0, which is 1/2 x. So this is your function, and again, x is between minus infinity and sorry, this is for when x is between 0 and 2. So let's see, like we did in the discrete domain, let's try to plot this function. This is capital F of x. So before 0, no, there was nothing. Between 0 and 2, we know it's a function. This is a function of a line, right? Half of x is a function of a line. At 0, it is 0. And at 2, what's the value at 2? 1/2 times 2 is what? Is 1, right? So we know at 2 is 1, and it's a straight line. This is an equation of a straight line. And then after 2, it continues to be 1. Why it continues to be 1? Because we know that f of x, we said before, recall, what's f of minus infinity? We know f of minus infinity is 0, and we know that f of plus infinity is 1, and we know that f of x is a probability still, like we did in the discrete domain. So it should be between, f of x is always between 0 and 1. It starts at 0 and it moves at 1. Here we do not have a staircase like we had in the discrete domain. We have a smooth curve because we are adding areas as we move on. So since we are adding areas, then there is no jumps. There is no points at which there is a mass of probability that I will add. Of course, we are not covering in this course. We can have a mixed distribution where I can have part of the distribution is discrete and part of it is continuous, but we are not covering them in this course. We either have a discrete distribution or a continuous distribution. Okay, let's do another example, quick example before we take the absence. So given f of x equals, I'm giving you a certain f of x 0 when x is less than 0, 0.2x when x is between 0 and 5, and 1 when 5 is less than or x is greater than 5. If I ask you, find what's the probability that x is less than or equal to 2.8? One 0.2 times that value. So
integral
2.8.
integral
I'm
from
giving you the capital f of x, not the small one. Again, be careful. Don't mix small f. If I'm giving you f of x, you integrate from 0 to 2.8, the small f of x. But I'm giving you capital F of x. By definition, what's capital F of x is defined as what? Probability that x is less than or equal to x, right? This is the definition. So now I'm asking probability of x less than 2.8, which is the same as probability of x less than or equal to 2.8, which is exactly as f of 2.8. You just need to find the value of f at 2.8. So from the definition, f of 2.8 equals 0.2 times 2.8, which is 0.54, maybe? Is it 0.56? 40, 56? No, 0.2. Yes, 0.56. Right? Yes. Is it clear to everyone?
Doctor, if I
Yes.
have small x, integrate between two limits. But if I have capital X, capital F, just substitute directly.
Yeah, just based on the question, of course. But if I'm asking you to find a probability of x less than or equal to certain value, then yes. This is the capital of x. This is the role of capital F of x. It gives you the probability of x less than or equal to a certain value. But if I ask you this, probability of x greater than 1.5, what do you do? This is greater than, not less than. Remember the rules of probabilities? So probability of x greater than 1.5. This is the complement of what? This is 1 minus probability of x less than 1.5, right? I can write it this way. Yes, some of you figured it out. So which means that this is 1 minus f of 1.5. And what's f of 1.5 from the equation? This is 0.2 times 1.5, which is 1 minus 0.3, which is 0.7. Good. I like the third question. This question I have in my slide. So he's asking what's probability that 40 less than x less than 60. Again, by definition, the probability between 2 points, this is probability of x less than 60 minus
big
probability of x, yes,
Big F of 60 minus big F of 40.
yes, which is f of 60 minus f of 40. طب what's f of 60 and what's f of 40 based on this definition? What's the value of capital F of x? This range, right? If x is greater than 5, then the value of f of x is, so this is simply 1 minus 1, which is 0. Just again, just follow the definition and what's given for the function that we are defining. Finally, let me ask this: what's probability of x greater than 6? Probability of x greater than 6. I like this example. Again,
1.
let's see. And again, as I said, don't play it very smart in the. So this is 1 minus probability of x less than or equal to 6, right? This is the complement. So this is 1 minus f of 6, which is, what's f of 6? Capital F of 6. Again, 6 is greater than 5. So the value of f of x is 1. So 1 minus 1, which is 0. And so on. So always make sure that you use the definition of capital F of x, small f of x, whatever you are given. Last point I want to mention here, the relation between small f of x and capital F of x, which we did. We defined capital F of x as the integration, which means that small f of x, I can get it just by taking the derivative of capital F of x. If f of x is the integration of small f of x, then small f of x is just the derivative of capital F of x. So in the above example, what was f of x? It was 0.2x between 0 and 5. So f of x was 0 when x is less than 0, 0.2x when x is between, and was 1 when x greater than or equal to 5, which means what's small f of x? I take the derivative. What's the derivative of 0? 0, x is less than 0. What's the derivative of 0.2x? 2, when x is between 0 and 5. What's the derivative of 1? Derivative of any constant is 0, then s is greater than 5. So this is your f of x. If you plot it, small f of x, so it's constant between 0 and 5, and this is 0.2. Let's double check. What's the area? Area is 5 times 0.2, which is 1, which means it's indeed a valid probability density function. Okay, so let's probably it's a good point to take the absence. Sijoy, can you please get into Blackboard and
Okay,
enable
Okay, doctor.
the attendance, and please, for you guys, take a minute or two to get into Blackboard and mark down your or check in your attendance.
Dear students, you can now start to check in, please.
Yes, Omar, you have a question? Omar, do you have a question?
Yes, doctor.
Yes, go ahead.
The question where you said Px is greater than or equal to 40 or less than 60, I don't understand that one.
Okay, let me do it. Did you do your attendance?
Yes.
Okay. So in general, whether it's for discrete or continuous, let me put this as a side. Generally, probability of A less than or equal to B less than or X less than or equal to B is probability of X less than B minus probability of X less than or equal to A. This is a general rule. If the probability between 2 points, both in discrete and continuous. Of course, in discrete, you have to be careful if you have less than or equal or less than.
Okay.
For continuous, it does not matter. So this is the rule that we used it here. So, and each one of them is f of 60 minus f of 40. And then we found 40 and 60 from the definition. They are both greater than 5. Then the value of f of x is 1 at those values. Okay?
Okay, clear.
Okay. Mashallah, we dropped to 31 after the attendance.
Doctor, 34 checked in during attendance.
Okay. طيب. So we did the small f of x, capital F of x. The two other ways that we talked about previously are the mean and the variance of a random variable. So mean and variance. And as we mentioned, and always remember that mean is the expected value or tells you about the location of the random variable, while the variance tells you about the spread of your random variable. So for a random variable x, we define mu, which is the expected value of x, as integration from minus infinity to infinity x f of x dx. So exactly the same. We had a summation of x times f of x. In the continuous domain, the summation becomes an integration. So we just integrate f of x and we multiply it by x. And the variance, sigma square, which is v of x, which is the expected value of x minus mu square, is integration from minus infinity to infinity x minus mu squared f of x dx. Exactly the same. Just replace the summation with an integration, or easier way to do it is x squared f of x dx minus mu square. And if you recall, we defined the standard deviation sigma as square root of the variance. So this is very, very straightforward. Let's do the mean and the variance for the above examples. So considering the above example, where f of x was
Doctor,
0. Yes,
why we never talked about standard deviation when we were doing discrete probability?
we did the variance and the standard deviation. We defined the standard deviation. Yeah, I'm probably
But
we defined it. Maybe I did not include it in an example, but
we
يعني
focused a
standard
lot.
deviation. Go ahead.
Uh,
Continue your question.
we focused a lot more on the variance than the standard deviation.
Yes, the variance and the standard deviation, they both convey the same message. Because one is the square root of the other. So they both tell you about the spread of the random variables. As we will see, it depends later on what application you are talking on. Later on, if you do communication, the variance will be the main, you will use it more. It reflects the power of a signal. The variance of the signal reflects how much power I have in that signal. Standard deviation is used more in statistics. If you will do as we'll see when we talked about normal distribution, and it has to do, we will always be interested in ranges under the curve where mu plus sigma or mu plus 2 sigma. So standard deviation is used more in statistics, or the variance is used more in applications like in communication. But they both reflect the same general idea about the random variable. They both increase if the spread of the random variable is wide, and if it's narrow, then they both decrease. Okay? So this was point 2. X is between 5 and 0, and 0 when x greater than 5. So let's do, what's the mean? In this case, mu, by definition, integration from minus infinity to infinity, x f of x dx. And in this case, we know that the range is between 0 and 5. X times what's the f of x is 0.2 dx. Then what's the integration of 0.2x? 0.2 over 2 x squared, right? From 0 to 5, which is 0.1 times 25 minus 0, which is 2.5, which is expected, right? Because my random variable is the same between 0 and 5, so we expect the mean to be just in the middle. We can also do the variance. Variance is just integration, again, by definition, from minus infinity to infinity, x squared f of x dx minus mu squared. So in this case, it's integration from 0 to 5, x squared times 0.2 dx minus 2.5 squared, and which is 0.2 over 3 x cubed between 0 and 5 minus 2.5 squared, which is 0.2 over 3 times 125, right? 5 times 5 times 5, 125 minus 2.5 times 2.5 is 625, I guess, 20 or 625. I don't know, so you just calculate it, and this will give you the variance. Standard deviation, just take the square root of this value. Okay? So this is the mean and the variance, the way we calculate the mean and the variance of a continuous random variable. Exactly the same way that we did for the discrete random variables, just we replace the integration with the summation with the integration. The last point I want to do is, for today's lecture, is the expected value of a function of a random variable. What does that mean? So given a random variable x with a probability density function f of x, then if I ask you what's the expected value of h of x, a function of the random variable, and simply you just do substitute that function and you multiply it by f of x dx. Why is this important? For example, in the I think all of you should got, or you should have done the circuit class. If we have the current I is random, we don't know exactly the value, especially if it's fluctuating, and you have certain, you know, the average of the current. If I ask you what's the average of the power over a resistance of 1 ohm, then it's I squared. So it's random variable square. So you are getting the expected value of x squared. So let's again continue with the previous example and see what does that mean. So for the above example, find expected value of x squared. Expected value of x squared, we know that just take the same function inside, so it's x squared f of x dx, and this it's exactly what we did. So it's from 0 to 5 x squared times 0.2 dx, which is 0.2 over 3 times, it was 125, 125. If I ask you what's the expected value of x plus 1, I will define a new random variable, which is my x plus 1. What's the expected value of x plus 1? Simply, you just apply the rule, this rule. What does the rule say? Take the function inside and multiply it by f of x. So this is integration from 0 to 5 again. X plus 1, f of x, which is 0.2 dx. And then you carry out the integration. So it's 0.2 times x squared over 2 plus x from 0 to 5. Then this 0.2 times whatever, 25 over 2 plus 5. And so on. You can plug in any function that you are interested in. Let me do one last example. I think we have like 6 minutes. I will do one more example. Okay, let me do this example. I will not start the families of random variables today. So this example says that the probability of the weight of packages delivered to a post office is characterized by f of x is 70 over 69 x squared 0.5 less than x less than 35 kilograms. So this is the distribution of the function. And then I can ask, let's just lay down how to solve this problem. Maybe you can continue at home. I can ask you, prove that this is a valid, prove that it is a valid f of x. What do you do if I ask you this question? Prove that it's a valid f of x. You need to prove, you need to check two conditions, right? So check two conditions. Check one, f of x greater than or equal to 0. If we substitute any value, so here substituting any x between 0.5 and 35 gives a positive number, which means first just substitute x here, any value between 0.5 or 35, it will always give you, it will always be positive. What's the second condition that you need to check? You need to check that integration from 0.5. You need to check that the area under the curve is 1. 70 over 69 x squared dx. You need to check that if this is 1 or not. I will not do, but try do it at home. If you do it, you will find out that this is valid. The area is 1.
How do we prove condition 1?
You just like this. You write to me that if I substitute any number between 35 and 0.5, it's x squared, right? So you are squaring that number. So it will always be positive. If this was, for example, 69 times x minus 2, then it will not be valid, right? Because when I substitute 0.5, x minus 0.5, 2 minus no, x minus 2. 0.5 minus 2 is minus 1.5. So it will give you a negative answer. So just you have to write to me if it is valid, then you said, yeah, like I write here, substituting any x between 0.5 and 35 gives a positive number. So it's always positive. So you can write, it's better to write f of x is greater than 0 for all x in the range.
Here it's because of x squared. The first example we did, it was because of e power x, right? Which will also
yes. It will become tricky, as I said, if you have x minus something, or minus x, or whatever. So in that case, you need to look carefully about it. Second condition, for sure, you need to solve the integration. This is an easy integration, x to the minus 2. So it will be x to the minus 1, and then minus 70 over 69, x to the minus 1, and then you find out whether it is the integration adds to 1 or results in 1 or not. If not, then even if the first condition is fulfilled, if the second condition is not fulfilled, then it is not a valid f of x. Of course, determine the mean and variance. I can ask determine the mean and variance, and very simply again, you just apply the rule for the mean 70x over 69 x squared. Then this becomes tricky because it's 1 over x. Then you should know that the integration is the log, and the variance is 0.5, 35, then 70 x squared over 69 x squared. The variance is easy because it will those will cancel. Of course, you can cancel x because 0 is not in the range. If 0 was in the range, then there's a problem with the question itself. So 3, I can ask you if the cost is $3 per kilogram, what is the average shipping cost? So now I'm not interested in the average of the weight itself. I'm interested in the average of the cost. So x is the weight, y is the cost, and he's telling us that y equals 3x, because it's $3 times the weight. If you have 1 kilo, then $3. If you have 2 kilos, 3 times 2, $6, and so on. If you have 35 kilos, it's 3 times 35, which is 105. So just, it's like I'm asking you indirectly, what's the expected value of 3x, which is the integration from minus infinity to infinity. Again, 3x f of x dx, and in this case, you can take the 3 outside. Integration from minus infinity to infinity x f of x dx, which is 3 mu that you found already here in this step. When you find mu, you just multiply it by 3 and you get the average cost of the shipment. Okay, I will stop at this point. So we finished characterizing continuous random variables. We are ready to start talking about three important families or distributions. Next time, inshallah, on Monday, we'll talk about the uniform, the normal distribution or the Gaussian distribution. That's the most important distribution in this course, and then the exponential distribution. I wish you a safe end of weekend, and we'll talk to you on Monday, inshallah.
دكتور المتر من العيدرس
المتر من البداية up to probably will be able to finish the joint distribution. I think till the end of the joint distributions. We'll see how things will go, but most probably we will reach that point.
Okay.